This is my long ISP 2D Servo Sonar mapper. Here's a demonstration of it working. First, it will ask you to select the color, either red, green, or blue. Then it will ask you to scale a minimum and maximum. The reasoning will be explained further in this video. Next, it will ask you to set the dimensions of the window, and lastly, it will begin mapping. The way it works is at every degree in a 2D window, it will take the distance and then map it out on a scale from black to the most saturated version of either red, green, or blue. In this project, we'll use blue as the example color for everything. This project begins with a distance sensor. The TF Mini Plus is a distance sensor that measures anywhere from 0 to 12 meters. The TF Mini sends out 9 bytes of data during every pulse. The first 2 bytes are frame headers, essentially used like an address. Bytes 2 and 3 are the distance, 4 and 5 are the strength of the signal, 6 and 7 are the temperature, and byte 8 is an accuracy check. This block of code is used to retrieve data from it. First, an integer checksum is created, which is used for an accuracy check. Then, communication with the sensor begins, and all the bytes are loaded into the URAT array in this for loop. Further, the integer checksum is equal to the sum of all data. After the for loop is complete, the last byte in the data structure is sent, but not added to checksum. This byte is then compared to checksum to ensure that the reading was accurate and all data was successfully transmitted. If so, then the distance bytes will be properly converted to centimeters. Next are the servo motors. To map out a 2D perspective, 2 servo motors are used, one for a vertical axis and one for a horizontal axis. These servo motors only have 3 wires, power, ground, and data. They use a PWM signal to determine their rotation. Each pulse is 20 milliseconds long, and the duration of on to off will determine the position. For example, 18 out of 20 milliseconds will be at 162 degrees, and 5 out of 20 will be 45 degrees. To efficiently map out a 2D window, a snake-like pattern is used. Here's the code for the mapping. The function begins with a Boolean direct value. This value is used for changing the horizontal direction from left to right to left. At the end of each sweep, this value is flipped. Next, a for loop is opened, where it starts at the lowest y position and will end at the final y position. During each iteration, this for loop will add 1 degree to the vertical servo and sweep all the way across the horizontal. First, 2 integers, xpos and turn, are created, where in this while loop, the x servo will continuously rotate until it is equal to the turning point. As you can see, during every degree, the pixel distance is retrieved and printed out on screen. After this while loop, the value of direction flips, which now means that xpos is equal to what turn was initially equal to, and vice versa. Also, the rotation of the degrees will flip with this ternary statement. Next is the scaling feature. What this feature does is allows the user to determine the minimum and maximum values for the most saturated color and black to be designated to. Basically, if you know you're mapping something to only 1 to 2 meters away and want to ignore everything else in the background, you can set the maximum to 2 and minimum to 1. This means that everything 1 meter and closer will automatically be set to blue, and everything beyond 2 meters will be black. The left would be a properly scaled map, and the right would be a map that was set to default. Next is the color mapping. On the LCD screen used in this project, RGB is on a 15-bit scale rather than the typical 24. This means that each color, red, green, and blue, will have 5 bits designated instead of 8, which means that each color can be used on a scale from 0 to 31. Here's the code for color mapping. If the distance is less than the minimum, the color will automatically be set to blue. If the distance is greater than the maximum, the color will automatically be set to black. Otherwise, the mapping process will go through, where the color, from 31 to 0, will be mapped from minimum to maximum. Here's a close-up of the final encasement. And here's a time lapse of all the pieces being built.